We have a lot of flasher issues in here. I don't know, you know, everybody's turn signals don't seem to want to work. There's 2-pole flashers and there's 3-pole flashers. A 2-pole is just like this. It's very simple. Basically what it is, if you've ever had one apart, if you look at this, you can pass this around, there's a couple little coils here that heat up. And they're on a strip of bimetallic material, 2 dissimilar metals fused together. When you heat it up, it warps and it breaks the contact. Once it cools down, it makes contact again. That's what you're hearing when your turn signals are running. But you can see how those things are constructed. There's not a lot there.
That's why you can't use your LED straight across.
No.
You're relying on the heat up. And,
yeah,
right.
LEDs don't put enough juice to heat up those elements.
Right, right. We're going to talk about that. So that's a flasher. The difference between a 2-pole and a 3-pole, usually, again, I'm talking generalities. There are some different weird circuits out there. But usually the 2-pole will be on the cars where the way the turn signal switch is wired, you have 2 indicators. So you got a left and a right. The 3-pole, one of those poles will be labeled P, usually, and that pilot, or that's the single indicator on your dash that just tells you turn signal's on, doesn't tell you which one. Okay, but those are flashers. This guy, voltage stabilizer. Okay, let's talk about this for just a second. We run into this issue sometimes. If you have a electric temperature gauge or an electric tachometer, electric fuel level gauge, remember the equation here, ohms, resistance, voltage, all tied in together. We'll picture a fuel sending unit, and what it is, it's a rheostat. When the float comes up, the resistance through that changes. Okay, so you're using that difference in resistance to vary the voltage getting to the gauge to make the needle on the gauge move. Great system, simple engineering. Here's the problem. When you're at idle and your generator is only putting out 12 volts and your battery's at a 12.5 volts, you'll get one reading. Now you're cruising down the freeway at 55, you're putting out 13.5 or 14 volts. What happened to the math? As the voltage went up, it affected everything else. So the gauges would be all wacky. So you need a way to stabilize that voltage that you're using as a reference to make the gauge move. And that's what they call voltage stabilizer. It's really nothing more than a faster reacting flasher. It's basically the same principle. I've got one here, and if you can see the wire on it, your eyes are better than mine, but you can pass that around. That's what's inside that voltage stabilizer. The little tiny strip of metal on top there that heats up, and when the voltage goes up, it pops open, closes, open, close, so that you get a steady voltage to your gauges. That's what the voltage stabilizer is for. MGs have those, and they can be a problem. Sometimes they'll just, you can see how fine the wire is, they'll just burn out, and then your gauges won't work. Those particular gauges that run on electricity. So. The other thing we have, in some of the later Bs, we have diodes for those seat warning buzzers and whatnot, things like that. I don't know, Sam, do minis have seat warning buzzers and diode system and all?
Yeah, in the 70s.
Okay. Okay. A diode basically, here's a schematic diagram of a diode. It's basically a one-way check valve for electricity. It'll let electricity flow one way and not back the other way. And so where you'll see them is a lot of times in some of the more modern cars, the charging systems and stuff like that. Your alternator has a series of 4 diodes in it. That's what they call a bridge rectifier. And that's how it converts AC electricity to DC. And I won't get too far, or your eyes will glaze over if we start talking about that. I'm already losing some of you here. So. Capacitor. Okay? What the heck's a capacitor, and what are we talking about there? Every car with points has a capacitor. They call it a condenser. The best way to think of that little device is spark suppression. What it's there for, when your points are opening and closing, on those lobes of that distributor cam are firing those points, without a good condenser capacitor in that system, they'll arc at the points instead of at the spark plug. Well, that'll quickly burn up the points. If you ever look at your points, and you'll see one contact will look like this with a crater in it, and the other contact will have a spike in it. That's from the arcing, the metal going away from one side to the other. Doesn't necessarily mean your condenser is bad. They rarely go bad, but they're so cheap, and they're usually included with points. If you're still running points, I would change it every single time.
So sometimes I've found in the past though that putting a new one in didn't necessarily gain or guarantee the fact that they were going to be any good. In reality, if you have a good one, sometimes
You want to hang on?
Yeah.
But you can
Gee,
really tell.
new parts that are defective.
Weird.
In reality, what you really have to recognize is what happens when your condenser doesn't work right. And it's when you look down at your points and it looks like somebody put chalk on them and they're all sort of grayish, chalky.
Yeah, they're all burnt up.
That's, that's pretty much a sign that your condenser's not working.
Yeah.
Or if the engine stops.
Yeah.
Or say not,
That's the smoking gun, yeah.
Not as good as it should be.
Yeah.
Has a hole in it someplace.
Then we have resistors, a thermistor. Okay, what the heck's a thermistor? If you've got an electric water temperature gauge, you got a thermistor. All it is a resistor that varies the resistance with temperature. So when you heat that bulb up, the resistance changes. Just like, remember the float level in your gas tank for your gas gauge? Moves up and down, changes the resistance on the little wire. This does it inside that. It doesn't have any mechanism in there, it's solid state, but when it heats up, the resistance changes because of the metal it's made out of. And so that runs your temperature gauge, if you have an electric one. Okay.
If your temperature gauge isn't working right, that's the first thing you should go look at.
Yeah. Well, and we're going to talk about diagnosis, but there's a real quick test for that. And this is where
the wire and your gauge goes to hot. So.
exactly. All you have to do is you pull the connection off that, touch it to the block while somebody's watching the gauge. If it jumps over to the high side, you know your gauge and your wiring and everything should be intact to that point, and then you know your sending unit's bad. That's a quick diagnosis. If you touch that and nothing happens, then you got to see, is the wire broken? Is the gauge bad? Do I have power to the gauge? Blah, 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 all that kind of stuff. Right?
Indeed.
Okay. Of course, ground, battery, fuse. British cars have, no.
Yeah. They have fuses?
I was going to say lots, but they don't. Yeah. 2, 4, some of the later Bs and Spitfires, they jumped up to 4 fuses. Yeah, the minis, yeah. Why is that? I have no clue.
Because they didn't need them. They didn't anymore.
Well, and you got to think of it, again, in terms of the times. They didn't anticipate people adding a bunch of stuff to the cars, you know. The one thing I would say about fuses is, this drives me crazy, used to drive me crazy at the gas company when I trained guys there, is that, you know, when something fails, I've had a lot of people say, oh, my fuse blew out, it's probably just a fuse, I'll just put a new one in. There's usually a reason that fuse burned out. Putting a new fuse in might get you home.
A bigger one even.
Yeah. But you may discover it was doing what it was supposed to do. Yes?
Well, there's a not really critical point here too. The British used a different system for rating fuses.
Exactly right.
And it's a dangerous conversion because a British 30 amp fuse is not like a US 30 amp fuse.
Yeah. If you actually look on the side of them, have we got fuses in here, Chad?
Yes, I believe so.
Okay.
With the piece of paper in there.
Yeah. The ones with the paper inside, what he's talking about, excellent point by the way, what he's talking about, you'll see right here, 25 amp continuous. Okay? Lucas, 50 amp. Okay? That means this thing will carry 50 amps for a very short while. But it's really only rated for 25 continuous. But if you see that 50 amp on there, and you plug a 50 amp into this circuit, and you haven't discovered why it blew in the first place, your wire is quickly going to look like this wire.
Well, then you'll quickly know why it happened.
Yeah, maybe.
The car is currently up in flames.
You're going to smell smoke real soon. Yes?
Right where the problem.
So the point is, generally, British fuses are rated for twice what a US fuse is rated for. So
Yeah, in a short...
if you're replacing a 50 amp UK, replace it with, well, the closest you can get to a 25 amp AGC.
Right. Exactly right. Yeah. Really good point. And sometimes those are really hard to read in there. But yeah, they have a different way of rating fuses. There's continuous and
How
intermittent.
does it compare to a slow glow fuse?
Well, a slow blow fuse has a little mechanism in there that will let it kind of overheat for a second and then blow. And I don't see them too much in automotive stuff. I wouldn't, to protect my wiring, if it were my car, I would go with no more than the original rating for a fuse. And there are, and that's probably the biggest tragedy we see is stuff with burnt up wiring harnesses. Now we don't have Healy Club members here, but the Austin Healys are notorious. The rear license plate illuminator is glass, of course, and it's the rearmost portion of the car, and the little chrome surround it is extremely thin and sharp. So you can have your Healy parked in a parking lot, somebody backs into it, breaks that light, and the way the wire's routed, that metal will cut into the wire and set your car on fire. There's no fuse for that.
Oh my God.
So what we do, we install an inline fuse, we hide it down in there so you don't see it, it's still historically accurate, but it keeps your car from burning down, and that's a good thing. Originally the Healys had a battery cutoff that when you shut the ignition off it de-energized things, but a lot of people do away with that. And so that circuit is energized all the time, and if somebody bumps that wire or shorts it, it will burn your wiring harness up in that car. Yeah, it's scary.
You can sell replacement smoke in a jar. So
Yeah.
if you get smoke out of your wire, you can get replacement smoke.
So,
Actually, that comes in the form of electrical tape, I think.
yeah. Okay, so any questions at all on those are the basic components. They're all the same on all the cars. They may be located in different areas, but again, once you kind of know how they function, yes.
Yeah, I noticed you talk an awful lot about Lucas, but you know that this is the Lucas system that we're dealing with, basically. It's also Smith's.
Well, that's true.
So
true.
where do you stop blaming Lucas?
Well, I like I said, I really don't blame Lucas. I think
I don't either, actually.
Yeah.
I have nothing against him.
I think the majority of the stuff I've seen in my couple years here, actually doing this as a profession, I hate to say it, but a lot of it's operator induced. You know, rewiring stuff, adding stuff, port connections, port splices. There's some just outright failure, and anything can fail. That's the thing. You can have a brand new part, and we have kind of a policy here. If it's something that, personally, if it's something that I'm going to be installing up under a dash and it's hard to get to, that's why I built this little test bench. I will test it on the bench before I ever put it in the car, because I don't want to spend a half hour bolting it in there only to find out it didn't work. And we have had that, sadly. We do our best. I know all the shops do their best to get the best components, because that's just wasted time. We're never going to charge a customer for that, so it's on us, and you don't want to waste your time putting a defective part in. Or the worst for us, our absolute nightmare, is to put a part in and a week later it fails. Well, those were mechanical fuel pumps, but we had, what was it we had that we went through a run of where?
Pretty much bolted in the car, it fails.
Yeah.
Well, like the Penalite rheostats, that was a huge
Yeah.
debacle there for a while. That it was so poorly made that like the very first time you try to decrease the rheostat, it pretty much peels the soldered on backing right off and that's it. So that's like a $25 part. It failed. The first time you try to decrease your lighting to your instrumentation,
You touch it, it breaks.
yeah.
And that's not Lucas, that's aftermarket. Yes?
So John, what about the electronic distributor, the Patronics? What's your professional opinion on that?
Well, first of all, the Lucas system of the MGBs in 76, 77, their electronic system, I don't get near them, they scare me. I don't know how they function at all. No one does. I don't think they ever released their internal, how that system works, and they're unavailable, and they just scare the heck out of me. I'll share with you, I don't want this to turn into, telling horror stories of stuff we found, but I'll share with you one other common thing.